Hello. Hello and welcome to a series of tutorials on Python, which sit within the series of tutorials on the introduction to software in robotics. Let's dive straight in. In this video, the first video on the series of tutorials on Python, we'll cover two things. The first is I'll give an overview of the language, so provide context for Python within other languages. What makes it particular, what makes it different. And then later on we'll go over the syntax and some of the things that you can find in Python's standard library. So this will be the most essential, bare essential things that you need to know in order to successfully write your first Python program. That's longer than Hello World, but something interesting to you. Okay, so let's dive straight into the first point. Language overview. Every language is designed with a particular use case in mind. There's no but there are jack of all trades types of languages, but that's a specific use as well. If you want something fast, to be as close as possible to the hardware, to the design of the CPU itself, then you would use something like C. If you don't need to be so granular, but you still want to be fast, you just want to have a bit of an easier time coding, then you would use something like C++. If you want your language to be portable as possible without you doing anything, then you use Java because it has the JVM, the Java Virtual Machine, and so forth and so on with many different languages out there. The purpose of Python is to be, in a way, the simplest possible language to use. Now there are others, competing for the same title, but Python is the most popular probably. And within the context of engineering, it's also very, very useful and very widely used for prototyping. So you want to see whether something even makes sense. It's somewhere between 20 and 500 lines of code roughly. You whip out a Python script to see whether it makes sense. Now, of course, you can keep adding things on. It's not like the language forbids you to go any further. It's just that some of the particular design choices will hinder you if you want to have a sort of a big project. At that point, you want static typing, stuff like this. But for this use case, it's incredible. It's very, very good in scientific computing as well, and that's maybe more due to the packages that it offers for this purpose. But the language itself certainly is still very good for this use. So what does this? How is this achieved? There's no free lunch in any kind of optimization. So the fact that Python was optimized for the speed of development, essentially, traded off, the trade-off there is the speed of execution. So instead of you thinking, oh, what is this type that I need to have? What is this list? How can I, tell the computer to do this or that? Python has default choices for you, essentially, so that you don't have to make them. You don't even have to think about them. And then the computer does this thinking for you, essentially. And that's what makes the language slow. It's 80 to 100 times slower than C for the same task if you use the standard library. Now there are there are some ways around it depending on your use case, but typically it's super slow. I should note though that often you don't have, if your use case isn't particularly complicated, it's fine that the program is slow. There's, depending on the application, the speed doesn't really mean anything potentially. So like I said, it's very, very simple to get into. It's designed for this, but I will say, if you want to be proficient in Python, there's a lot of layers to it. There's a lot of syntactic sugar that you know, normally we would dissociate with, like, I don't know, something you do to make your life a bit easier. I would say that there's so much of it in Python that it in a way changes the way you view and use the language, and that's becomes a bit more important if you're like writing and using or changing, you know, the Python libraries that you have. Then these things are not 500 lines of code; they're a bit bigger, and these additional layers, Python layers, really help manage that basically. And it also just, you know, makes for prettier, easier to read code and so on, easier to write as well. Okay. And a key feature of, well, not the language itself, but the ecosystem around it, is that there's an incredible, truly incredible amount of Python packages. So, you know, depending on what you're doing, the problem is most likely, you know, if you're just getting into things, then most likely there's the thing you want to do already exists to some level, so you don't have to do it from scratch, and instead you just use a package. And on this note, it's very important to note that since Python is written in C, it's actually possible to, you know, write more C stuff, C functions, import them into Python and use them there. So you could offload the critical execution, the times that takes a long time to execute, like various mathematical operations. You could have them written in C or C++, and then imported into Python. So that's sort of why it survives. Why you can run. You can write a controller for a robot in Python, because all of the heavy lifting math is done actually in a real language, let's say. Okay. We got over this already. Yes. So these are some more, a bit more technical details. Strong dynamic typing. That basically means that every single variable can have any type. Now this might sound like a bit esoteric, but what this basically means is that you don't need to ever assign a type to a variable. Even in lists, you can have many different heterogeneous types of objects in a list, and Python just eats that. The way this works is that every time you assign a new value to a variable, it's copy constructed, and that's the part that makes it slow. And because of this, there is no compilation. So Python runs your code line by line by line. If there's an error on line 36, the first 35 lines will be executed regardless, and you'll get an error only then. There is a way to denote types in Python, but I'm not gonna go into this because it's not, you won't really need it just when you're getting into it in that way. With this addition of typing, you would be able to check something before the program runs. But yeah, we won't do that in this tutorial. Okay, and so one benefit that you get with executing line by line is the fact that you can use a shell as opposed to a script or a programming file, where you input each and every line of code one by one, and then you change them on the fly, and it's a nice interactive experience. And finally, there's a notebook, which is like a collection of shells that you have all on sort of one. They're in they're on the web browser, implemented in like JavaScript or whatever. I will show you all these free things now. And yes, then we are done with the presentation. We're going on to the code. So first, let's see how a script would look like. Let's see, any old example will do for this. All right, so here you have some importing of the different packages. Here you have some function, And here you have if name equals main. Now you don't need to have that in Python. If you had only this, only these parts, that would be executed as is. People put this in so that, you know, if there's something defined like a function, like this this function, you can import the function without running the rest of the code. So that's why you hide it this way. But if you were to invoke this this script with Python or Python 3, and then the name of the program, then it would run it and it would execute the main. So the other parts of the code just sort of sit there. Okay. Now when it comes to the shell, there's a Python shell just as it is. This is, you know, it works, but it's very ugly. What you should use instead is IPython, and you can install it just like this, and that will provide you a bit of a nicer interface. That's where it will work, so I won't talk more about it at this stage. Instead, I wanted to show you a shell. Sorry, a Jupyter notebook, one that's already that already exists. Let me just find one real quick. Okay, that's the one I wanted. There we go. And I need to run that from a particular directory. It's a Docker because the packages that this IPython notebook uses will be they're defined in it's shipped in a Docker, but you could just run it as Jupyter notebook normally if you had the packages installed. But I really like this one particular notebook. That's why I wanna open it up. Pinocchio tutorials, and then it's this one. Okay, so we had this saved. Let's run it. There we go. Where did this open up? Over there. Okay, let me just hide my face. There we go. Okay. So this whole thing would be a Jupyter lab. I never really used labs. That's not what's sort of important for me. It's these notebooks. So you can have like text. It's almost like you're reading a book basically. And then at some point, you know, there's a whole bunch of code that's being shown. And if I were to very quickly just run some of this, you can see that you can embed plots and or even a bit more advanced visuals inside. Let's see, it has to run a bunch of things so that we can get to this point. Maybe I should have chosen something that doesn't run for so long. Is this? Yeah, this is a bit faster. There we go. So, you know, within the notebook, you can have even like an interactive plot kind of thing. And yeah, this is very, very convenient to have. I personally don't really use notebooks for myself. I use it when they're given to me like this, because I like the interaction between the shell and the script. Okay, let's move this out of the way. Put my face back on. Okay, we don't need this anymore. We just kill it like this. Okay. So what do you use okay, I'm using the shell because it's a very natural thing to use, you know, to show something off. But in general, at least for myself, as I'm writing a script or a program, I have a side window with the shell running, and then I'm testing out my commands. You can even sort of import, if you do IPython e and then something.py, then you would get the program would execute and leave you in a shell at the last line. And that way you can play around with the variables to see what you have at a particular time, or just verify some computations, check how some functions work from a library before you put it into the script. I don't really debug Python directly apart from just using the shell, and you can play around with whatever you want until it works and does what you want. Okay, but now we're finally ready to start talking about some of the syntax. Okay, so as I mentioned before, you take a variable, you give it, some value on the side. In this case, the integer 13, and now if you were to check the type of A, it would be an int. Now, I should note, I am sort of in this tutorial, I'm guessing, I'm hoping, I'm sort of, what's the word? I'm hypothesizing. No. I'm assuming that you have had a course or some experience with some other programming language other than Python. If you haven't, I implore you to take a course, read a book, whatever, online material where they would explain, things like what a variable is. I'm just assuming things like this here, and what are types and so on. Anyway, if I were to now give some string value to this A, now it would become a string, and that's the same variable A that we can you can check the memory if you want. Let me see, check my notes for a second. Okay, I will move this point over below. Okay, now let's talk a bit about, so those are types. It's all you have all the standard types that you know already. There's nothing new and crazy going on here, really. Now let's get into the data structures. So there's quite a bit of data structures that are predefined and that you can just start using, and they're built into the syntax. So one of them would be a list, and here we have a list containing an integer number 1, a string that's a number that says number 2, and a string B. If you want to access one of them, you access them via index, where the enumeration starts from 0, but you could also index in reverse, which is interesting. You can add something to a list with the append, or I think you can even do it. Now this is like the syntactic sugar type of thing. I personally don't like ever using this because the plus operator here is overloaded, and this can be confusing because things like this you pretty much only are able to do in Python. So it's a bit evil, as people like to say. So all lists are mutable or changeable. At any point, you can remove something from a list. Yeah, the same sort of in IPython, at least, you can tab complete things the same way you do in a shell. So this is how I got this little window here. Let's see, if I pop, I think I'll get the last element, second to last element. Interesting. Because this didn't save. This created another list, and it didn't change the list A. Now if we look at A, it removed this pop thing, removed the last element, and it spit it to us here. If you can, of course, save this to a variable. Now, a very, very, very important note on lists. They're dynamic lists, if you know what that is, but that's also important. But what's under the hood. But what's really important is if you have the list, and you pass this into a function, you're not passing a copy of the list into the function, you are passing the list itself. So even if you refer to it by another name, if I were to do b is equal to a, and now I do b dot append 1, 2, 3. So it's b is the list a that we had with this appended. This will change a as well, because they're passed by reference by default. And now if you want to truly have a different list, you need to copy it. So if I were to do b is a dot copy, now I change the list somehow. Oops. There we go. But a stayed the same, because now I actually did copy the entire list. This operation is O(n) complexity, if it's so linear complexity, and that's why we kind of yeah, I don't know. I mean, it's debatable what should be the default. Anyway, the default is, as I said, and as you just saw demonstrated. Okay, now lists in Python are obviously very powerful, because yeah, you can do whatever you want with them. You know, you can index them however you like. There's even more advanced indexing than what I showed, but now you can just Google Python and list indexing if you want. I'll just keep going to the next data structure, which is a dictionary, and this is a thing with the curly brackets. So it's in a way like a list. It's just different elements that are separated by a comma, but now you have pairs instead of individual elements. There's a pair of the first thing is called a key, and the second thing is called a value. So if I were to do a dot keys, I would get the keys. If I do the values, I would get the values. And why do we care about this? Because you can now access different elements via the key, not via, they're not enumerated, right? So this is not a thing. For this to work, this would have to be one of the keys in the dictionary. This is a very, very powerful and very, very convenient way to store separate things that you know what they are because you've created the keys yourself. Now, of course, the keys could be anything. They could be any type. But basically what I'm saying is you can generate keys that make sense, that make it very easy for you to access some data in your code if you don't want to define a whole class just for this, and if you want the number of things to change and so on. I very highly recommend that if you have like a collection of something to think, is this better to be would I profit more if this was a list or a dictionary? They are also mutable and function the same way as lists do with these copy things. There are other predefined structures within the Python standard library, but I think like these are the main two that you'll encounter. And again, please do try to use dictionaries, because one thing that is observed quite often with new users of Python, they realize that lists are super powerful, but then their code has a lot of management of indices. So they have like 3 different lists, and sometimes they use this or that element, or they have like 2 lists which are of equal length that are somehow related to each other. And that code, where you heavily rely on some clever thing you're doing with the indexing, is incredibly difficult to read. Both for you, it will, your head will hurt as you're writing something, and it's also certainly very difficult for someone else to read this. And the dictionaries, from my experience, help with this particular problem a lot. Okay, now let's get into what computers are good at. Repeating the same commands over and over again in loops. There are 2 kinds of loops. There's for and while, classic stuff as in any program. The most typical way you would use a for loop in Python would be something like this, where you select this range essentially generates these numbers that you store in the variable I, and here we just print I. You can change this I sort of on the fly. Not that I recommend doing this, but you can do it. The next one will still be defined by the range. But importantly, you can, very importantly, you can iterate over anything. Does not have to be a range. Anything iterable, or anything that's an iterator. These are technical terms, but what they mean essentially is if you have a list, or a dictionary in this case. In the case of a dictionary, you would iterate over keys. But anyway, the way this looks is you do for an I in A, no matter how long that is, you just go over every element. In this case, this would print you the keys. That's how they work. But if I were to do the value with the key, then I would get the values. Same thing goes for lists, but then you just get the element. That's very, very convenient. Although importantly, you shouldn't change what A is in this for if you're doing it this way. And then you have a while loop where you set, this would do something forever. Importantly, the signal, the kill signal still functions within the IPython shell. So if you don't want to repeat something forever, you can stop it this way. The reason why you would use a while loop instead of a for loop would be because you have some sort of a logical condition upon which the loop ends. So you don't know how much you should repeat this particular chunk of code. You're not going over every element in a list, but it's just some number of times. One example where this could happen would be if you're doing something like optimization. You're writing a gradient descent algorithm or something. You don't know how many times it's gonna execute, but you know that if you know the math and it converges, you just want to do it until it's done, basically. I think I did write some very small example including this. So IPython also remembers the history. That's why I'm kind of demonstrating here, and you even have comments for things like this. So let's say we have a classic squared function whose derivative is 2 times x. We're starting at the point x0 is 5. We're at the 0th iteration. I think with this we'd also need to, what did they call it? Doesn't matter, we'll see now. Step size, initial step, what do they have? Doesn't matter, we'll write it from scratch. Step length, I think they called it. Gradient step length I need as well. And I need let's say the change in the value of x, which we set to something huge in the beginning. Now we say while change is greater than 0.001, what I want you to do is to compute the next iteration. So we're doing gradient descent. The next value of x is the initial one minus the gradient times the gradient step size. Then the change is the current one minus the previous one. The previous one minus the, let's do it this way. I should actually use the absolute to make it. There we go. Now it doesn't matter. Now let's print some of this. I should also increase the iteration. You can do a plus equals like this, sort of like in many other languages. And now let's just print the iteration number. Let's print the current value. After I calculated the change, I have to set the this would be the next old value basically. Okay, and now let's also print the what was interesting. Yeah, the change. Okay, run this, and okay, in 43 steps we got to. Oh, I didn't print change actually, but yeah, I mean, who cares? So I didn't know how long this would run. This would be like a small example of, you know, writing something in Python. It's very, very to the point, as you can see. Now let's get into the following topic here, which would be functions. So functions, as you know, are chunks of code that you want to repeat at some number of times, you know, somewhere. You just want to have this a little piece of code accessible. In Python, you define a function by the keyword def, then its name. Let's say SO2. That would give me a. So this I want to define a function that would give me a rotation matrix in two-dimensional space just from the parameter data that I give as input. You know, that's something you would, you know, probably want to do many times if you're doing something something in Lie groups, or, you know, in robotics, if you have a planar task and you need orientation. You know, sometimes you want the angle, sometimes you want the rotation matrix. So be this way. I hit it with the colon here, and now it's very important that there's indentation here. You probably noticed this with the while as well. So in Python, and this indentation, the white space here, that's one tab. I don't think it's even strictly defined how long it is. If you know, typically it's 4 spaces, but I think you can, if you put 2 consistently, I think that would work as well. And yeah, the function stops being defined, not necessarily with a return, because you don't define the type of the function either. Like this data could be a string. This is very important also, so to have in mind. Like you have to take care of the fact that if you expect a float here, that you put in the float here. If you put in a string, the code would just continue executing, and then you get like very, very strange errors if you're not checking for this. That's why, you know, for longer code, there is like support for some kind of typing now, so that you check this in advance. But again, we're aiming for relatively short, simple code, so there's no need to introduce this. Okay, and let's say I want to give this as sort of a double list. So this would be my rotation matrix, would be cosine. Oh wait, I need to import the import math. Okay, let's get back to this. Define SO2 from theta colon R would be just a list, where this would be math dot. Let me verify that I'm doing it correctly. So the first. How am I? Now I need to think a bit about this, because there's a math package that you can use that I will introduce in the following video, but I now just want to rely on the built-in Python functions. So the first thing would be my my first row, right? So cosine theta math.sine theta. Now I close the first row, I go into the second row, and that is minus sine cosine, that's right. -1 times this. I think if you just put in the minus, that would work as well. This is just a bit easier to read. And now I close the upper bracket as well. And I want to return this R. Okay, so let's give it some number, value for theta, and there you go. I got my rotation matrix defined from this angle. You know, this is what you would typically use functions for, stuff like this. And now finally we have classes. Now, classes are essentially a way to bundle variables and some functions together into a cohesive unit of something. This is very abstract. That's kind of the idea. They could be practically anything, and they don't really serve a purpose in the sense that you have to know this in order to program. Like, for example, what you do need to know what variables are. You probably need a list and a for loop at some point. But you could have the entirety of your code could function with just functions and what I've mentioned so far. But classes are so ubiquitous in a plethora of languages because they serve this purpose of helping you to manage your own code, to translating your ideas and what you want into a programming language. That's why they're just very, very common. And instead of writing an example here, I will go to show you of let's say you have a double pendulum. This is one of the libraries I found online. I apologize for not crediting it to who wrote it, but the double pendulum is a whole software package in Python. And anyway, let's say you have this double pendulum that you want to control. Then to do this, you need to model. To have a model of it, to know the derivatives of its state variables. How do you integrate your velocities into positions, stuff like this, and what's the mass, the length of the of each of the pendulums. This is something that it makes sense to bundle together so that you have all of this information accessible at the same place. Okay, so. At the parameters, let's look at the plant. So this is a very, very long piece of code, but I am showing you something like a bit more interesting, a bit more complex, because typically in libraries that you use, you would find something a bit more complex, and then for your own purposes you use something a bit simpler, of course. But it's very good to read the source code very often, to fully understand what's going on. Typically, people put the documentation up front inside. I think this way it sort of appears in various helper programs that help fill out something as you're programming, like if I do a numpy.something and I hit the tab again, you get an expansion like this. And if you put your if you put some documentation like this, then you would be able to access it. Now, this is in my particular setup. I use some particular shortcuts for this, but the point is that you get it. Other software just extracts this, in a different way with some other shortcut. But yeah, it's here. To define a class, use the keyword class. Typically, people denote these with starting capital letter. These brackets are used if your class is inheriting from something. I don't think we'll encounter this anywhere, but so I won't introduce inheritance, but it's like you have a more generic class that's specialized into something else, and this sort of the child class has everything that the parent class has, and then you change a few things, add a few things, whatever. Okay, so I have this documentation for all the things it has. Now there are some, so this is one associated function with the class, and there are predefined functions that a class can have. I'll introduce here the most important one. That's the underscore init. Typically, these predefined standard library functions have these underscores around them. So when you instantiate an instance of this class, this code would be executed. So it expects all of these things to be provided. I won't go. This is the way you would predefine sort of like a default value. I won't get into what are positional arguments and the other kinds of arguments. It will be kind of obvious, and you can Google this basically. So these are all predefined. The positional ones are like the self, where it's not necessarily predefined, or it would be something like this. And you have these after the positional arguments, which you have to have. Okay, and then with the keyword self, you store a variable within the class. So very sort of expected thing. You have the init, where you put in some data, and you store some of this data. You instantiate something more, maybe do some pre-computations that will be necessary, and so on. The way you would instantiate the class would be, I don't know, my pendulum, double pendulum, and then it would, you would have to provide it with all of these things, or nothing in this case because there's no positional arguments. And you can, of course, have multiple instances of a class. Okay, let's see if there's something else that's interesting. Okay, so now we have like our own function, let's say. Here we define the forward kinematics for the double pendulum. There's some math going on here. And still we have this word self. Essentially, you always want to have it. What this means is that you are passing the instance of the class as a first argument, which just means that all of these, you will get access to all of these as self.something variables. It's almost always there, like 99% of the time. We have a method to compute a mass matrix, Coriolis matrix, gravity vector, and so on. So you bundle all of these things together, and then if you had a different object or a different dynamical system, that could also be its own class. But and again, you don't really need to have this in a class. You could do it some other way, but this is just a very, very convenient way to make all of this a bit more understandable. And now this is like a 700 lines of some class in some library, but as you can see, it's like very clear and understandable. This is very often in open source code you get something that's meant to be read by other people. No, not every time, but the people do try, definitely. And yeah, this concludes our overview of the syntax, Python syntax, some of the features of the standard library. In the following video, we'll go over some of the packages that people typically use, and I'll just throw in this or that part of the standard library as we need it, essentially. I do have to advertise basically at this point that if you go to let me just quickly hide my face. Can close this. Let's just go to maybe it's better. You don't have to be distracted by my many tabs. Python documentation, in fact, standard library. So this document is absolutely phenomenal. Okay, I don't think I've ever in my life that I ever saw online documentation for a programming language or a package or a whatever that's as good as Python's standard library documentation. Here you have all the information on the other built-in types that I've skipped over. There's plenty of examples of everything that you could possibly need. The detailed sort of explanations of what's this or that you can copy paste into your and then play around in the shell or in a script, whatever, all of these different options. You can see the different types of functions that are associated with these, like base types or whatever it is. And very importantly, I have to say, there's a huge amount of predefined functionality that exists in the Python library. So for a lot of these things, you don't need to download a specific package. What I would highlight of these things is, of course, the I/O. So how do you open a file, read and write to a file, stuff like this. Pickling is very useful for saving any kind of object. So you can have like a huge list that's some number of megabytes big, and you don't even have to be worried of how would I write this into a file, what kind of functions can I use. If you pickle it, there's like a specific Python way of saving every Python object, essentially. This is very useful if you want to get some quick and dirty logging going on. The whole language is again sort of like its primary design purpose is to be used for quick and dirty computation. It's in my opinion unparalleled in this, but then again I don't have I use primarily Python and C++. I'm not as familiar with other languages. Maybe it's just that they do better advertising. Okay, you can read a CSV file. Here you have access to various different operating system services. Like, I don't know, checking if you want to create a different directory. Let's say from this, you don't need to call on mkdir or make directory. As a shell command, there's essentially the shell command just accesses a particular function that your OS gives to you in its programming interface, and you can access this programming interface from Python as well. Now, of course, it's not as extensive as the shell, but but you can even run shell commands in Python, which can be very useful, because with the Python you can very easily do something to this data, with the lists and so on. It's like very, very powerful. And we have threading and processing as well built into the language itself. This is like now became sort of a miscellaneous sort of factoid gauntlet, but very importantly, there's no real multi-threading in Python, in the sense that if you create another thread, that it will still use the same CPU core. However, with processing, you will in fact be able to use a different CPU core. This is one of the many peculiarities of Python. I am mentioning this because I do have some multi-threading or multi-processing going on in what we're getting to, which is the library for robot control. This is why I'm mentioning it now already, so that if I repeat it many times, you'll know it. There's you can do networking, and again, this is excellent documentation with plenty of examples. In conjunction with man pages and so on, there's you could learn pretty much everything that exists in programming, of the standard things, just with Python man pages and this documentation. I cannot again highlight how good this is. Of course, if you're just Googling something very quickly, you get some answer from Stack Overflow. That's totally fine. Especially if you just want to know one specific piece of information. But if you want to learn a bit more in depth, this is like a great resource for the standard library. Okay, with this, let me put my face on so that I can say bye. Okay, with this we conclude this tutorial. I hope you learned something. I hope it was relatively interesting to do this within the scope of this tutorial. I hope that now you feel a bit empowered to go further on your own, that how to learn a bit more, what are some nice resources, and of course that you basically know enough syntax to start hammering out your own projects, your own code. Thank you and good luck in your programming adventure.